There she is. Well, good afternoon, ladies and gentlemen. Welcome to AP Stats. Thanks to one of our students who shout out to thanks to Marcus for letting us use his Surface. And I understand sometimes when you're using the Surface, if you're in the National Football League and it's too cold to take your gloves off, you can just use your nose. Just use your nose to flip from one page to another. That's what we learned from the football players. Here we go. Random variables. Tell me, what types of variables have you learned about so far in mathematics?
Non-random.
Independent.
Let's keep it flowing. I've heard. Sometimes two different variables can be independent or not. Let's just talk about individual variables. Individual variables fit in to what different types? What types of variables do we have? Okay, we have quantitative variables. Let's put types of variables. Types of variables. Okay, one is quantitative. And if you have a variable, then it has a name, a value, and a domain. I like to think of variables as boxes. Here's a box, and this could be quantitative variable x.
Perfect.
Okay. So here's quantitative variable x. Its name is x. Its value, I'll put 2 pence in here. Its value is 2, and its domain is the set of real numbers. So every variable has, like x is an example of a quantitative variable. It has a name, x, it has a value, in this case 2, and it has a domain. What other types of variables are there?
Categorical.
There's categorical variables, categorical. And so let's take a categorical variable like survival. Thinking of the Titanic. Everyone on the Titanic had a survival value of either alive or dead. So name, survival. Value, either alive or dead. The domain was all possible categories in survival, alive and dead. So there's a third type of variable we're going to learn about today called a random variable. Random variables are always named with capital letters. So notice we usually use lowercase letters for quantitative variables. So I have to be careful in my handwriting so you can tell what I'm writing. I usually put a little tail on my lowercase x's, but my capital x's looks just like that. Here's a capital Y, random variable Z, W. So they're named with capital letters. The values are always the outcome. Let's just write this down a little bit. Name is going to be a capital letter. The value is going to be the outcome of a random or chance process. Outcome of random/chance process. And the domain of a random variable is really, could be, we could randomly select whether you live or die. So we could randomly select a category. We could randomly select a number. So it could be any number or any category. Any number or category. And my $300 stylus has seen its last days.
No.
So it's time to switch over to a new $300. No, actually this is last year's $300 stylus. So we're going to use last year's $300 stylus.
Wait, is this the one you used in calc before you switched?
Well, no, this is, I've got 3 of them in that desk drawer.
That's
Don't tell anyone that I have 3
Someone could rob you for
$300
$900 with a
styluses. But any number or category.
Get myself into
Random variables. Usually random variables are quantitative, but they could be categorical. Just any random process. Like, for example, if you take a spinner. Yeah. Like if you have a spinner in a game, and suppose you've got, the spinner can point to one of 6 sectors that are like, maybe you're playing a kid's game where you roll a spinner and you say green, blue, or purple. Or, so then the domain for this random variable when you spin the spinner would be either green, purple, blue, red, orange, or white. So that's an example of a random variable. So now we are going to look at a real world example of a random variable, example 1. And I want to let you know where we're going today. By the time you walk out of here today, the goal is that you will know the formula for the expected value of a random variable.
I'm going to go with that on the board.
And what is this? Someone put random markings on the board. No reason to believe that any of those have connection with today's lesson. I'm back. So. And then we also have the goal of learning the standard deviation of a random variable. And like, I'm watching you, so. And then there's also the variance, VAR, the variance of a random variable. So these are the 3 formulas that we need to walk out of here with today. Just a quick announcement. I did send out a message about an AP classroom activity. Now, someone in my 4th period class piped up and said, hey, you know, Mr. Royce, you're not allowed to give AP classroom activities for grades. Which, someone else is fine. I'm really glad that people felt free to speak their mind. I don't know if that's true. It might be true. Either way, I was planning to use a cushioning approach. Probably what I'll do is I just want to give you some sort of completion grade. It's really important that you do it between now and Friday. So we might just do it like one of those GFA activities where you get either an 8, 9, or 10. As long as you don't have an epic fail, you'll get either an A- or an A+. And we'll see how that goes. If there's anyone who really gets less than 1/3 of the problems correct, then we'll just pray that doesn't happen. Or we could just do the completion grade that's either 9 or 10. Like you get a 10 if you get 90% or more of the problems correct, and you get a 9 if you get less than 10% of the problems correct. That way it's graded, but essentially everyone just is getting a completion grade. But the point is, it's up on AP Classroom. Finish it before you come to class on Friday. It's basically a review activity. Okay, let's do our first example. Example 1. Here we go. See if I can find this. Example 1. Not lockdown. Lockdown is something else. And here we go. Problem 1. Suppose we have a game. And in this game, it costs $2 per play. It costs $2 to play the game. And suppose we roll a 1,000-sided die. So there's a random process, or maybe we just use the random integer command 0, 0, 0, 999, 1. We're going to pick a number, one of 1,000 possible integers. And let's say, if you get which number, then you win $100. What number is going to be the winning number? This is your chance to participate in the authorship of today. What 3-digit number will be
126.
017.
326.
Are you 17 years old?
Well, yeah, but it's
Okay, so you picked your age. I want a number between 99 and between 100 and 999 inclusive, just for fun. All I'm asking is for a 3-digit integer.
172.
Well, there we have it. Okay, so that wasn't too hard to get to. Okay, so In this game, if you roll a 172, then you win $100. Now, we're going to define, since this is a random process, we're going to first of all find the expected profit. Because you're thinking, wow, I get $100 for winning. Maybe this is how I can support my family. Instead of going to college, I can just become a professional gambler, play this game 2,000 times a day, and that's how I'll be able to put food on the table, go out to Outback Steakhouse every now and then. Why am I still holding this? Yeah. Okay. And then, so that could be the plan. Well, you're going to want to find the expected profit per play. All right? Expected profit per play. So that's what we're going to find out. Now, we could, did you have a question? Or no? You sure? Okay.
Funny guy.
So friends, there's two ways to find expected profit. You could define your random variable either as the payoff from the game or the profit from the game. And we're going to do it both ways to see if we can get the same answer. But it just is a reinforcement of the Spherical Chickens posters message, which is LMBY. LMBY, you remember what it stands for? Let meaninglessness bother you. Wow. That is it. So we're going to attach meaning to the random variable. Let's let X represent first let's let it represent profit. To find the expected profit, we could let X represent the payoff from the game or the profit. Okay, so now X has meaning. Let's set up a probability distribution table, and we showed you kind of let's say a training wheels version of this before Christmas, but now we're going to take off the training wheels and give you the real deal. This will feel like an initiation into the mathematical community. This is like how real probability distribution tables for random variables are set up. We never used the phrase random, or we did not use the phrase random variable before Christmas. Now, since there's two possible profit options, I need two columns before the label. So profit, lowercase x. Here, these are the particular values of the random variable with lowercase. And then down here at the bottom, we have the probability that capital X equals lowercase x. Now, at this point, you might be experiencing some levels of increased anxiety because you might be thinking, wait, why, Mr. Royce, why are you mixing capital X's with lowercase x's? What are you trying to do to us? Might be what you're thinking or feeling. Well, that's what you're thinking. The feelings might be, there might be fear, could be sadness, anger, probably not the positive emotions like tenderness, happiness, or excitement. Could be. If you're feeling excitement right now, math may be the field for you. So, but you know what, friends? Let's focus on this because this is actually, it's very understandable, but it's potentially confusing. So whoa, careful here. One possible value for profit is -2. It could be that you play the game and you don't win, which means you paid $2, so you end up losing 2. What is the probability? In fact, I'm just going to write this. I guess I'll write it down below. What's the probability that capital X, the profit, is -2? Does anyone happen to know what % of the time this happens? Or what would the probability calculation would be? Yeah. Hate to say it, but 999 times out of 1,000, your profit's going to be -2. So we put 999 over 1,000 right here. What is the probability? What is the other possible value for random variable capital X? 98. It could be that you win $100. So it could be that you end up profiting $98 from that play. That happens 1 out of 1,000 times. And so notice why we have a capital X and a lowercase x. Capital X is the random variable. Lowercase x is the particular value of the random variable. So on the top of the probability distribution table for a random variable, we write out all possible values. Basically, the entire domain of the random variable goes up here. Particular values of the domain are represented by lowercase x, but capital X represents a random variable. So this, I mean, you don't really need that in your notes. Oh, well, it's there. Okay, so in the other class, I erased it. Let's find the expected profit. And it's possible to use these four numbers to calculate the expected profit per play. Does anyone have either a guess as to what you think the expected profit will be in dollars, or does anyone actually know what to do with these four numbers on a calculator in order to calculate the exact expected profit? I'll take either response. Does anyone just have a guess? It's like, what's the profit going to be per game on average? Val? Okay, so what Val said sounded correct. You take the payoff or the profit value times the probability plus the other possible value times its probability. So let's write down E of X. E of capital X equals, what Val said is correct. It's -2 times 999 over 1,000. And then Val, did you say then plus? Okay, so then we're going to add to that the other possible profit value, which is 98 times 1 over 1,000. This is the expected profit per game. So that's all you got to type in your calculator. Here we go. -2 times 0.999 plus 98 times 1 over 1,000. So -1.9, that you can expect that on average, you'll lose $1.90 per game. So the expected value of X is -1.9. And what it means, let's do this verbally, you can expect to lose $1.90 per game. I'm going to write it over here. You can expect to lose $1.90 per game. And expected value means the average value. So we wouldn't have to say $1.90 per game on average, but it does mean an average. So if you want to play, like suppose you say, I'm going to support my family. So you kiss your spouse goodbye in the morning. You say, I'm going to gamble. I'm going to gamble 2,000. Let's say I'll only play the game 1,000 times today. So, and then I'll take Marcus's question. But what this means is that if you play the game 1,000 times, you can expect to lose $1,090 that day, $1,900 that day, not $1,090, $1,900. But it's possible that you'd win every time. I mean, it could be you play the game 1,000 times and you win. I mean, you could come home with $100,000 at the end of the day. It's possible.
That would be nice.
Could be you'll lose every time. Could be 1,000 times -2. It could be you end up losing 2,000. But on average, like if you make this your life's work, you can expect that this life will cost you $1,900 per day to live this life. It's like, so you've got to be, maybe you've got to do a lot of Uber driving to make up for your lifestyle. Now, Marcus, you had a question.
Yeah, can you close that? It's like what you wrote up. So you said like let the capital X represent profit.
Yeah.
Then why does like the little x go in the profit?
Right, okay, see, and this is the part that seems kind of confusing at first. The lowercase x in a probability distribution table for capital X represents the particular values of capital X. So it's like capital X equals lowercase x value of -2. What's the probability that capital X equals this x value So that's why down here we say, what is the probability that capital X represents profit? What's the probability that the profit represents -2? Okay, if you put a -2 in for that, then you get this expression, which is 999 over 1,000. What's the probability that the profit equals, what's the other possibility? 98. What's the probability that it equals 98? So notice that in this equation, think of the symbol on the left is representing the random variable, capital X, and the symbol on the right being represented by lowercase x, which means a particular value of the random variable. Okay? So yeah, that was the right question to ask in order to clear up confusion and possible anxiety, or to reduce excitement, or maybe to increase excitement. Any other questions on that? Yeah, it actually got to the point, like around halftime, NFC Championship game, I'm thinking, I don't even want the Packers to win anymore. Because what if the Packers, like, you know, they throw a bunch of long passes, then they onside kick, and then it's like, then it would be humiliating in the Super Bowl. So they don't deserve to be in the Super Bowl. They're not good enough.
At least you're in the playoffs.
So, and then like quarterbacks are like random variables, because quarterbacks have names, they have values, like, you know, you got Tom Brady's quarterback. Okay. So then value is different quarterbacks have different values. There's dollar values, they have, you know, lots of different types of values. Just want to mention Tom Brady. I'm so glad he's not in the Super Bowl. It's one thing for the Packers to not be in, but
Yeah, Garrett.
if Tom Brady would have been in there, I really would have been upset.
That's all right.
Yeah. So, yep. I thought Rodgers had a good game. Now let's go and let's take a look at the formula. You need, now in general, what you do, the expected value formula, first of all, you need to know there's an alternate symbolic representation. Mu sub capital X. Mu sub capital X is another way to write the expected value. I like this other representation because it has the concept of mean in the symbol. It's like the average value. That's what expected value of a random variable is. It's the average value of capital X. And the formula is sigma, which means add them all up. I mean, if we had had 3 columns, we would have taken little x times probability of capital X equals little x for each column. It's like, you know, number times probability, number times probability. We would just add them all up. So it's take lowercase x times the probability of capital X equals lowercase x for all the possibilities. So that's the formula for the expected value of a random variable. Okay. By the way, standard deviation, let's calculate that right now. For standard deviation of a random variable, it's a big square root thing. And it depends on how many columns of numbers there are. Like there's going to be only 2 terms under the square root if there's 2 columns. Had there been like 3 possible profit values, there would have been 3 terms under it. And here's what it looks like. I'm afraid if I put it here, it's going to look too small. So I'm just going to put it on the next page. But you can put it right here in the upper right-hand corner. Here's the standard deviation formula. Oh, by the way, it also has an alternate symbol. It's sigma sub capital X. And here it is. Take lowercase x1 minus mu sub capital X quantity squared times the probability of, and here I'm going to let you in. It's not a secret, really. I'd be overstating it. It's not that dramatic. But sometimes instead of taking all the time to write probability of capital X equals lowercase x, sometimes we just shorten it up a little bit and just write lowercase x. I mean, that's just shorthand for the probability of capital X equals lowercase x. Hopefully you'll be able to tolerate that and not let it bother you too much. But we do that sometimes. Plus, and then next one. Take the second possible value of profit minus the expected value. capital X squared times probability of x2 plus dot, dot, dot. Just go as far as you need until you're done with the table. So let's use our calculators now to calculate the standard deviation of the profit. Yeah, if you don't have a calculator with you right now, go and grab one. Just try your best to not tackle Marcus's camera while you're up walking around the room. Like if you're thinking, he's gonna score a touchdown, get him. It's like, it's not a football player, it's just a surface.
Thank you, all spicy.
Just a computer. Computers are not people. All right, so now let's perform the calculation of the standard deviation of the random variable profit. Here we go. I've run out of room here, so I have to go to the next page. Hopefully you still have enough room there. So standard deviation of capital X equals, we'll write it down then type it into the calculator. Okay, so the first value of the profit is -2 minus -1.9. I mean, that's really, I'm hoping we can be honest with each other. That's just -2 plus 1.9, yeah, squared, times 999 out of 1,000, plus, and then the next one is 98 minus negative is plus 1.9 squared, and that happens 1 out of 1,000 times. Would you please attempt to type this whole thing into your calculator to get the standard deviation of profit? Here we go. So, taking -2. It's really plus 1.9. Okay, what's the next one? -2, no, next one's 98. 98 minus negative is plus 1.9, square that thing. Let's multiply it by 1 over 1,000. Close off the square root. I think, there we have it, $3.16 basically is the standard deviation. So the particular difference, or the typical difference between a particular profit and the average profit is $3.16. Now the actual difference will be either -10 or like almost $96, but on average, standard deviation is going to be 3.16. And that would come into play more if you're talking about playing the game many hundreds or thousands of times. Alrighty, so we have calculated standard deviation of capital X equals approximately 3.1, so $3.16. Let's turn this into a formula. How do we write down the formula? It's parentheses. I'm going to be writing kind of tiny here, but it's going to be lowercase x1, comma, mu sub capital X quantity squared times the probability of lowercase x1, which is shorthand for the probability of capital X equals lowercase x1, plus, and then it just keeps going. Do the same thing with, okay. If you have room, and oh, I can't believe it, I forgot to give you the alternate symbol for this. I don't know if it's too late for you to squeeze that in. Just like expected value of capital X, alternate symbol is mu sub capital X. Here, the alternate symbol is sigma sub capital X. Okay. It's kind of embarrassing to have only one term and then dot, dot, dot. So let me see if I can fit in two terms. So it's x1 minus mu sub capital X quantity squared times probability of lowercase x1 plus. Then x2 minus mu sub capital X quantity squared. Hopefully the people in China will be able to hear you, even though you can't see what I'm doing. Yeah.
No, they can't.
No, you can't see. Okay. Times probability of x2 plus dot, dot, dot goes forever. So I'm going to briefly show our international friends, that stuff I just wrote on the board. Here it is. So plus dot, dot, dot. There's two terms plus dot, dot, dot. So this is a risky part. This is like almost as risky as fake hunt. Told you. The vibrations from all your clapping might. That's, yeah, wow. Okay, so now let's do this calculation again. Let's find expected profit one more time, but this time we're going to use a different definition for the random variable. And because some people, when they're doing expected profit, their minds think differently. Not everyone thinks the same way. Some people, it's very common for people to do this. Problem 2, we're going to find expected profit from the game, same game, but this time we're going to let capital X, random variable, represent not the profit, but the payoff. How much do we get paid for playing the game? So we're not subtracting -2. So let's set up a probability distribution table for random variable X, where this time we're going to think of all of the possible payoffs. And then on the bottom row, we'll put probability of capital X equals lowercase x. So sometimes you get paid $0. Like if you lose the game, which happens 999 times out of 1,000, you get paid 0. And other times you get paid $100, which happens 1 out of 1,000 times. Would you please use your brand new formula for finding the expected value of capital X? Feel free to use your calculator. Please find the expected value of cap X. Get it? Cap, I said cap X. I don't know exactly what you're doing, but actually you can probably do it in your head, because a lot of people can do 0 times anything in their head, so that's 0, plus, and 100 times 1 over 1,000. So it's 10 cents. The average payoff is 10 cents. 10 cents per game. So, oh, by the way, please take a moment to calculate the standard deviation of the payoff using 0.1. Notice how you always have to use the expected value to calculate the standard deviation. 0 minus squared. Now, 0 and 100. You might be able to edit your calculator work so you don't have to retype the whole thing. Like for example, you can put this in as 0, 0, minus 0.1. I feel like I'm saving time. 1, 0, insert a 0 here, minus 0.1. There it is. There's a nice editing process. Notice how the standard deviation is the same. No change, it's the exact same standard deviation. So, standard deviation of the payoff is approximately $3.16 again. Now, some people, when they're trying to find the expected value of the profit, start with analyzing the payoff, because they're thinking, okay, 0 or 100, I've got 2 possible outcomes. And so then they do this. They'll say the expected profit is going to be the expected payoff minus the cost of the game. expected payoff minus the cost per game. This is a completely legitimate way to do the problem because notice if you take 0.1 minus 2, you get the same answer we did last time, negative 1.9. So you get to choose. You can subtract 2 at the very end, which honestly a lot of people forget to subtract the 2 at the end. They're finding expected profit, and then they end up finding expected payoff instead, and they forget to do that last step. So even though many students will do this, I don't recommend it because a lot of students forget to subtract out 2 at the end. If you want to, you can, that's fine. But you have to subtract 2 sometime. You can subtract 2 at the top end of the problem and just start analyzing profit from the beginning. Or you can subtract 2 at the end. Now, just reflect for a little bit on who you are and what sorts of things you tend to do in your life. How many of you see yourselves as being the sort of person who would like to subtract the 2 right up front and analyze profit from the get-go? How many of you would end up analyzing the payoff and then wait until the end to subtract 2?
The battery's low on
Battery is going to die. Fortunately, I think I knew we didn't have much time. Your battery is running low.
There you go, Marcus. Oops.
Oh no, what am I going to do? Fortunately, that's as far as we need to get today. So we're done. So Marcus, is there, what do you recommend is the best way for you to get that video to me?